right, you are welcome. In this section, I want us to look at descriptive statistics. Descriptive statistics. So we want to look at how to carry out statistics descriptively, like as we defined during our introduction section. That we have basically some functions that we perform descriptively. This is general. The same data set we used before, I will load it now. In time to come, we'll be using input data set so that you can also be able to have access to those data. But this one will be given the link, which I from my previous teaching class. You can see the link in the description section to download this one. You can download. So, but in the time to come, I will be using inbuilt so that you can just have access to it directly instead of downloading the data set. So I told you before that you need this tidy verse, very important for data manipulation, and it comes along with data set as well. All right. So in this section, we just first to look at our data structure. Right. We have loaded our data. Don't forget your working directory. Don't forget, I've already done that, so I will not be repeat that anymore. Okay. I believe you have understood. So you have to create that before you start your work. So don't forget that. All right, so this is our data structure. Okay, you want to look at the structure of the data. You just select this one and click, and this is what we have done before. We have glimpsed. Don't forget we glimpsed the other time, and that is what we got just at in different structure. So that the same thing we see that we are still looking at here under data structure. So we just type structure str for short to display our data. So we see the number of observations we have is 499 and 8 variables or columns. All right, so if I want to see the first 6 sets of the data, so we say head data. So when you run that line of code to give you first 6 sets. Okay, so you can see the gender, age, height, weight, race, major. Right, then here center. So we have this 6 first set. You want to see the last 6 set, you should do tail. Type tail here, data. So that is the last 6. So we can now start by first summarizing summarizing our data and can the summary data to see the structure of the data in form of summary. So you run this line of code now. If you can see your data now, here you can see you see for numeric variable, this is a character variable, this is gender. For those categorical variable, those are basically character variables. But this one is a numbers, age, height, weight, they are numbers. So you can see the minimum here. You can see the first quartile, median, mean, third quartile, maximum. So these are basically descriptive in nature. These are descriptive statistics that you can compute individually on your own. All right, you can compute them individually. Okay, for both weight, height, for basically for numeric variables and age. Right. So these are the things that you just need to know how to compute because you may need them later. So apart from the summary that you can get some snapshots, you can also do what they call minimum and maximum number functions. We have functions in R. You can just say minimum data, for example, height. I want to find the minimum height. So you can just use that function and run it. You get your answer, minimum height, or maximum height. And also do the same, get maximum height. Right? That is a maximum weight. Sorry, maximum weight. All right. So you can get maximum height as well of the students. Now range works differently. If you just run this line of for range, okay. I just assign to a variable. This is a variable now, okay. Don't forget this is a variable. I assign to a variable called RNG. All right. So if I run this line on it now, I can just run only this line. It's okay. But I can run both together, right? So that I can now call my RNG. I call my RNG to give me the range. For range is supposed to be maximum and minimum, but you give me two numbers. So if I run the RNG only now to give me two numbers, the maximum and minimum, they give me minimum and maximum together. Okay, my duty is to subtract, so I can just say for range, I can just say maximum. I've done maximum now. Let's say maximum max data dollar height, the minus minimum data dollar height. So that is our range formula for range. So but in the function for range here, it will give you maximum and minimum together. It will not subtract for you. Okay, so you are the one to do the subtraction by yourself. All right, so only you want to create a special function for that. Right, so you can have the summary. I mean, a subtraction here, 7.73. All right, so you can also use mean function. So just say you're going to find the mean age. You can just apply mean age, or you want to find the mean data age, comma. You want to remove the because not this data may contain some NA. I mean, when I say NA, I mean missing data. All right, that's what it means, missing data. So you want to say means data equal to true, which means that you want to consider missing data while you are running it, so that you not calculate mean for missing data. So it will remove that missing data area for you automatically, and compute the rest, so that you will not compute empty column for you as a mean. Okay, that is for mean. So you remove the missing data and compute the normal data for you. So because this one does not have missing data surely. So just in case it has, you can do the same thing for other function as well while you are running it, even for median. So median function is want to know the median weight, just run the line median, call the function median weight, or you want to compile the quantile. You know, if you share quantile, you have basically five components: minimum, maximum, and first quartile, third quartile, and the interquartile. Okay, these are the five components you have in a quartile. So that is what you observe in a box plot. When you plot the box plot, you observe that five components in box plot. Don't forget. So you give you the maximum, minimum, give you the first quartile, give you the first quartile is 25%. Okay, second quartile, third quarter is 75%, while interquarter is 50%. All right. Interquarter is usually different between 75% and 25%. That's interquarter. Okay. So we can just run this line. You are saying you are finding this first quarter now. First quarter. All right. You can change it to 75. Yeah, 75. That is a third quarter. That will be third quarter. Okay. Okay, that is a third quarter. Okay, I just change it now. This is the third quarter. So I can change it also to 50, 0.5. So give me 50%, give me 65.01. All right. So 75% give me 65.68. 25% give me 64.68. So that is how you change. But if you check, if you now interquarter range is different between the first quarter and third quarter, right? So you can just run interquarter weight now. Let's just run this interquarter weight, give you 1.36. The difference between first quarter and third quarter. So if you subtract first quarter, third quarter from the first quarter, you should be able to get a same answer, 1.36. All right, so then we have what was standard deviation and variance. Okay, so you can also do the same here. SD, just call SD data height for anyone who want to find SD for. So just run it on the line. So if I run the line, I have my SD 0.99. So with approximately 0.1. So you also have a variance. Also, you can just run your variance, which is approximately 0.1 as well. Okay, so that is how to run the variance and SD. Then you can also do some frequency here. For example, now I have a categorical variable here called gender, which I want to see how my table is spread, the number of my the counts, how many gender do I have, how many do I have for each group. I can run it here. Just say the table gender. So say 2474 for female and 2525 for male. So you can see table help me arrange them, count them, and group them for me. So that's what to use table to do. But you may want to do further by arranging them in form of a contingency table. You have a race, you have a gender, they are both categorical variable. All right. So I say table, race, comma, gender. So it will arrange them in form of a pivot table for me. For each race, how many gender do you have under each race? So that's what we do for me. So if I run this line of code now, giving me, we have Asian, we have black, we have Hispanic, we have white. So under each this one now to give me how many female and male we have. For Asian we have 176 female and 154 male. For black we have 309 female and 276 male. For Hispanic we have 633 female and 654 male. And for white we have 1356 female and 1441 male. So that is helping to spread my this. So that is that divider. So you can also find the percentage of each of them, or probably the proportion too. I can just run this line of code, okay, to find the proportion. So but I assign it to a variable called prop. All right, so you can create a variable called prop, any number, any or p, depending on what you want to call it, and do the same thing. So you see the same thing here, we just add prop.table to it. All right, prop.table, then you want to find the proportion of each of those, this thing we mentioned, proportion of each of them in there. So to give us proportion, okay, so when you run this one now, we have proportion of this. So you can run probe now and see what I'm talking about. So give us the proportion of each of them. Okay, look at it, different from what we got before. So this is a proportion, but you can round it up to a percentage actually to find it, because this one is 0.02 something is long. You can round it to two decimal place. Okay, so you multiply the probe we got by 100, then comma 2, which means make it a 200%. That multiply this by 100 and make it two decimal place. That's what I'm doing here now. I'm rounding it up. All right, so this I call this is my variable probe, which will give me this or this. Then I round it up to I multiply by 100. I round up to 2. So that's what I did here. So you can just click on this. Now I have this is 3.52%. Okay, for female, then 3.08 for female, then black 6.18% for female, then 5.52%. So white has the highest, 27.13% and 28.83% for respectively for both female and male. All right, so you can actually plot a bar for that, right? So for male and female, okay, you can plot a bar for it. So I'm going to be dealing with a plots in the next section in different categories. So I don't want to display too much plot here. That's why I didn't mention plots, because I just want to describe the data here, what we are looking at. So in the next class, we will now be looking at a different kind of plots. Okay, so I'm going to treat them separately so that I can be able to treat ggplots as well in the same set. So I will see you in the next class. Thank you so much for listening. Goodbye for now.